Alright, we've got an implicit differentiation question here, guys. So let's go with that. We've got to find dy dx in part A in terms of x and y. So, to find dy dx, the first thing I would do is I would divide both sides by 2. And the result would be that 5xy minus y squared minus 6 equals 0. Okay, now we've got to use implicit differentiation, which means we've got to know how to do the product rule and the chain rule with implicit differentiation. So let me go through it with you. The first term, the 5xy, what we have to do there is 5 times. Now, as I say with the product rule, it's left times the derivative of the right plus right times the derivative of the left, or left d right plus right d left for short. So the left term is x, and then we want the derivative of the right hand term, which is dy dx, okay, plus the right hand term, which is y, times the derivative of the left hand term with respect to x, which is just the derivative of x with respect to x, which gets us 1. And the whole thing's multiplied by 5, don't forget that. So that takes care of our product rule, guys. Now here comes the chain rule. This is one that sometimes confuses students a lot. So remember that we are taking the derivative with respect to x. So we do it this way. We say, alright, we can take the derivative of y squared with respect to y, and then we can multiply that by dy dx. Now you can see the link in the chain here. This is the dy term, isn't it? So therefore you can see that that is equivalent to dy squared with respect to x. But this little bit here is easy, and this is what we're after, dy dx. Do you see? I'll show you in the next line, okay, and then you'll understand. Multiplying out the bracket here, we've got 5x dy dx plus 5y. Now, what is the derivative of y squared with respect to y, ladies and gentlemen? Well, it's 2y, isn't it? Yes, it is. Do you see that? Okay, then times dy dx equals 0. Now, that's the chain rule part taken care of, and we're looking good, guys. So now we can just solve this for dy dx by factorising out the dy dx term here and here, and we get that. Okay, do you see? This term gets you a 5x, that gets you a minus 2y. Taking this little guy over the other side, we get minus 5y. Now we can solve that for dy dx very nicely, and I've just basically done two things in the one step there. I've multiplied through by minus 1, and I've divided both sides by what's in the bracket here. After multiplying it through by minus 1, I get that answer there. Okay, that's that one done. Now we've got to do part B now. We've got to find the values of dy dx when x is 1. Alright, well the first thing I would do is I would substitute the value of x is 1 into this thing up here, okay? And then hopefully we can solve that quite easily for y. So let's do that. If we substitute x as 1, we're going to get that, 5y minus y squared minus 6 equals 0. Now that looks like a nice little quadratic for us to solve. So let's do that, guys. You know how to do that. So therefore we get y squared minus 5y plus 6 equals 0, making it a little bit more friendly, multiplying through by minus 1. Now that's a nice little quadratic for us. There it is, factorised into linear factors, and by the null factor law we know that y minus 2 equals 0 or y minus 3 equals 0, and therefore y will be 2 or y will be 3. Isn't that great? So now what we can do is we can substitute the value of y equals 2 with x equals 1 into our equation for dy dx, and it's easy. There it goes, 5 times 2 over 2 times 2 minus 5 times 1, which gets us, what does it get us? 5 2's are 10, and that's 4 minus 5 on the denominator, that's minus 1. So the answer is minus 10, guys. So now let's substitute y equals 3 and x equals 1 into the thing, and we'll see what we get. Okay, so 5 times 3 over 2 times 3 minus 5 times 1, so that's 15 over 6 minus 5, which is just 15. There you go. So when x equals 1, we know that dy dx equals minus 10 or plus 15. Put a box around your answer and you're looking good.